All right, folks, I see my friend in the back is telling me we're at time. We can get started, and this is just a 45-minute session. So I'm going to get us talking about computer vision and what are the computer vision services and tools you can use in Azure. Now, today's session is focused less on the DNNs and the science and the hardcore AI behind the services. We're focused on real use cases with real customers, and I'm very lucky to be joined by a couple of our customers today, Petra from Primo and Jason from Knowledge Lake, who will be talking about their own use cases of computer vision. So you take away one thing from the session today is that the services I will show you, they're all real, ready to use, and they can drive real transformation within your business processes or apps or industries. So let's get started. It's no surprise the world runs on software. Folks here are using your phones, you have your watches, you have your thermostats, your cars. It's all software. Software has eaten the world, as one of our luminaries has predicted. And more, it's running on AI, right? AI is starting to permeate everything in your lives, from, again, the same thermostats that you're using to your cars. And the AI that is being infused is no longer the stuff of labs, right? 5 years ago when we started working on computer vision, we were just a lab in MSR, just working on incubating technologies. The AI technology now is scalable. It is generally available as services and tooling in Azure and ready to be used by enterprises at scale. When we think about AI at Microsoft, we take a pretty comprehensive view of it. We refer almost to AI in terms of the same way we refer to human senses, right? And humans, they see, and we believe machines can help humans see more keenly and accurately. We know that humans need to hear, and they need to speak. And similarly, machines are able to help humans do those tasks with higher and higher accuracy. And lastly, humans are able to process and understand language, and we're evolving AI and machines to be able to do those same tasks and aid humans in those as well. Now, today's session, we're not going to focus on AI in general. This is just a brief intro. Today's session focuses on computer vision very specifically. And computer vision allows you to process visual data, whether that visual data is encapsulated in scanned documents or images or videos. It allows you to process that data at scale and know what's in it with zero metadata. We just work on pixels. We don't need you to annotate stuff in the images. Now, as I was mentioning earlier, today is less about the gory DNNs that we work on, although I'm happy to answer those questions. I'll be around for a few minutes after this session if you want to talk about what's under the hood. Today's session is very focused on real industries and real scenarios within those industries. I only picked 3 for today's session because we only have 45 minutes, but depending on what your use case is, please come and chat with me afterwards. So the 3 industries we picked for today are media and content, finance and insurance, and retail. Let's start with the first one. In media and content, this is an industry that deals with sometimes petabytes of data, petabytes of images, scanned documents, videos. And in such an industry, digital asset management is very important. Digital asset management is the process that allows you to sift through those petabytes of images, videos, or scanned documents. It allows you to automatically annotate it, store it, and then later reuse it. Instead of your user-generated content or your latest marketing campaign collateral becoming stale somewhere in an Azure Blob storage, you can use these digital asset management processes to make that content discoverable over time. In Azure, we provide a lot of the building blocks that go into digital asset management as a process. We provide image understanding, and this is a concept that encapsulates things like image tagging and image captioning and object detection, and we do this stuff at scale, at 1,000 scale. Our image tagger, for example, it can understand north of 12,000 different concepts today. And if you need to localize objects in key frames or in images, you can do that in the thousands of objects as well. We can do optical character recognition. There's an Azure service that's able to extract any text, whether it's printed or handwritten, in scanned documents or images. We also do what I'll call million-scale celebrity and face recognition, because our services allow you to do 1 million celebrity detection if you want to detect celebrities, or if you have face recognition MVP scenarios. Again, we support that in the million scale as well. And last but not least, we provide what I call low-code and low-ML, in a sense, hooks to allow you to customize these capabilities for your own uses. So we have a custom vision service that allows you to easily build your own object detection and image tagging models. This is the laundry list of services that you can use already today that encapsulate all of that functionality described on the right-hand side. If you go to Azure Search, Computer Vision, Face, Custom Vision, and even Video Indexer, all of these various capabilities are either natively baked or you can easily hook up in those services. Now we have a deep dive to tell you more about digital asset management, and I build the Lego bricks for digital asset management. We work with partners like Petra here, who's joining us from Aprimo. She's the VP of Product. And Petra will talk to us about how Aprimo uses digital asset management and the building blocks from Microsoft to provide real value to customers. Thank you, Petra.
Thank you. Good morning. So let me first situate a bit the DAM in our Aprimo product solution, because the DAM, the digital asset management, is not just the only part of what we put to the market. So we like to think that our solution is an experience command center. What does that mean? We actually allow brands to manage content, processes or operations, and performance on the rich customer experience they have to bring to market on their brand or their product. And obviously, making sure we manage the content is a big part of that solution. It's full Azure multi-tenant SaaS. So our customers are larger brands, enterprise scale, global. And as you can see, we service verticals which are highly regulated. So financial services, retail, CPG, pharma, healthcare, life science. These are all companies, brands who care very much about the trust on Azure. And this is actually also the reason why we run on Azure and why we try to keep all the AI that we implement also inside Azure if we can. Because these companies just don't like their content to travel outside of Azure. Now, when you look at having a DAM as a brand, the main challenge that these brands have today is actually make sure that the content they pay for, this engaging content, that it is actually being used and reused in their global enterprise. And so if they come to us and say, we want something on AI, it's definitely going to be around that ROI. So you will see that what I will show you today is very focused on finding content and being inspired by content that you didn't know was in the DAM. And for that, we actually leverage different services, almost all of the ones that Cornelia actually put on her slides. And so what we do, we mine content, we tag content automatically, we provide content suggestions, you'll see that, and we also provide cropping suggestions. So pushing campaigns out to Facebook, to ads, banners on websites. Often you really have to crop, resize your original image. And because we actually capture a lot of visual information, we can actually serve up cropping suggestions automatically from the DAM based on the AI. As you can see, two of these topics are in pink because these are the topics we can actually extend with custom-specific learned models to actually take into account also the products or the brands or the people which are very specific or the vocabularies of our customers. So to go from generic to very specific AI flavor on that level. But let's just show what this means in reality. So what you see now is the front door, our homepage on the dam. This is a test system, my test system at home. And you can see that actually it looks a bit different than you would expect from a dam, because also here we push content spaces, so subgroups, to audiences to make sure we pull them closer into the content without them making them search. But obviously this is not the topic of today, and I'll see if I can get this going. You can obviously also search for content. So let's search for cocktail. Neither of these assets come up because there's metadata. So all the searchability here is actually driven through AI. So the asset was tagged automatically. It's also served the cropping suggestions, but obviously we're serving marketeers, so if they want, they could reposition crops if they don't like them. But I can say that about 80 to 90% of the AI-based cropping suggestions will be right out of the gate, right? So other assets turn up because they match on cocktail. Let's have a look at the video.
Hey, this is Ed with Aprimo. I'd like to invite you to an Aprimo-hosted cocktail hour to kick off.
So just because Ed is actually mentioning cocktail in the video, that's the reason why this turns up in search. And here, obviously, it's very obvious why this turns up in a cocktail search. All of these assets were just uploaded. There was no human intervention of somebody adding metadata to actually surface this content. Same if I search for Get the Advantage, you can see our t-shirt comes up just because it has Get the Advantage written all over it. But let's do a bit of more wide search. Let's search for JPEG. I can actually be inspired because we can actually serve up similar items just by the analysis we've done through the AI. I can also do that with faces. And this similarity search I can actually combine with facets, metadata facets, but also with other search. Like now I can search on the color red, also comes in through the AI. I can just go for red in general, look what I have in my database, and then say, okay, this is like a band playing, I like that. Show me similar items. Okay. Maybe I'm looking more for like a festival mood of band playing, so I can do similar items on this girl in the festival, and you'll see that the imagery which is turned up is actually more festival-like band playing now than it was theaters. And this is all done through the visual analysis of the AI. What I couldn't show you today, and what I have on a slide, is actually business-specific tagging. So what you've seen is we actually tag the imagery and the videos automatically on generic terminology. But if you have very specific content, which often our customers have, we can plug in customer-learned models, and we have a customer games workshop, probably known better as Warhammer, thank you. You're probably familiar with these type of games. I was not, but it's actually figurines, small figurines, which you have to buy, paint, and then go and play war games. This is absolutely difficult to tag manually because these things look alike, and so Games Workshop uploads about 150,000 new assets yearly, and they are drawings and pictures from one figurine, groups of figurines, details of figurines, and I can tell you, the hair of one thing looks like the hand of another. So it's not easy to identify by a human person, but we built a model on custom vision, and this model tags correctly 94% of the incoming content and gives 9% false positives. Sorry, I didn't see, still had to build this one. 9% false positives means that you'll get a tag which is wrong, meaning that if I go for a search, the asset will turn up in a search where it wasn't meant to be. The math does add up because there are figurines who get 2 tags, right? So this is a good thing. When do you stop? You can obviously keep on refining that model and try to match for 100%, but it's basically about matching human parity or going beyond that. And I can tell you 94% is above human parity here. We built this in a code with track with Microsoft, which helped us very much to get to the point pretty fast. So a couple of key learnings I want to share. If you're in an AI track, you may recognize, or if you're starting, I hope you don't have to learn it the hard way then. So I think, AI is still junior. So we really run into the boundaries of AI from time to time. Probably it has to do with the sheer amount of volume and content that we deal with sometimes. I can tell you, when a sports association starts uploading footage and imagery on a whole sports week in one go, and wants to find that in an hour later, that's, well, testing the boundaries of the AI. And this is not just the API, the scalability, it's also our implementation, obviously. But we're learning. The sky is the limit. So if you ask a customer what they're expecting from AI, it's definitely magic. But as a developer, you have to balance well how much magic you're willing to deliver, because if you move from generic AIs over learn to self-learning AI, the cost goes up. The investment to develop it, the cost for running and rebuilding the models, but also the potential discipline your customer needs to have to run it. And so it's for each functionality a trade-off of how far are you going, where do you stop, and thank God we're fully SaaS. We can just slice it in and make that decision agile on the go as we build up the functionality. AI is not a one-size-fits-all. We started out by making a tagger which worked on all the content. That wasn't the right thing to do, because there's a lot of concerns. For instance, cropping suggestions makes no sense on the profile pictures of your board members or on product shots with white backgrounds. It makes sense on the content which is meant to do social campaigning. As an example, facial recognition may not be applicable to part of your database for privacy concerns. So we now made our AI completely opt-in and contextual. It runs rule-based where it needs to run and doesn't affect the other areas in the dam. But the main message here is probably that the real magic you're cooking is the one you cook yourself. So in the beginning, we thought we could actually match an API using an API to a feature. But it's only when we attempted the smart cropping suggestions that we understood there was no AI API helping us to get there. So then we started this architecture, if you could call it that way. What we really do is we leverage many APIs. We can combine them with custom learned models. We obviously have a lot of content and data we know of, and we put our magic on top of it. So we put our own secret sauce on top of it to build good AI applications. Not only in the dam, by the way, also in the other areas of our application. But the main message is it's really catchy. Once you get going, there is no stopping. We have so many ideas of what to do next. I hope you're a bit inspired. Thanks.
Thank you, Petra. Thank you. So the cool thing that I like about how Petra tells the Aprimo story is that, as you could see on, let's go to that previous slide she was showing, there's a bunch of building blocks that we provide in Azure that are building blocks to help you achieve a real solution in computer vision. And with Aprimo, that's what they do. They use these various building blocks, but like Petra said, how you mix and match them and how you decide how to apply them to your real business case, that's where a lot of the cool stuff comes in and where a lot of the value comes in. I like that Aprimo specifically looks at how to do intelligent workflows on top of the AI output of our services and how to do business rules around them. That's key stuff when you try to infuse AI into your business processes. Now, let me move on to the next piece of our talk, which focuses on, I clubbed together finance and insurance into one industry. They're two separate industries, obviously, but I clubbed them together because they both rely on lots and lots of paperwork, right? Scanned forms, scanned receipts, scanned documents. Those kinds of document workflows literally run through the blood of companies in those industries. And in these industries, we believe that document workflow automation is a key process that can really help simplify how a company deals with these tomes of scanned documents. We believe that AI can supercharge how you need to deal with documents, invoices, and receipts because it can help you extract the key value pairs you're interested in. And we'll show you in a bit how you can do that. And I'll do a shameless plug here for a second. We have our friend Neta Heibi, who's covering a whole session on form recognizer specifically. When is it, Neta? At 1 p.m. So if you guys can get lunch quickly for half an hour and you're out of here, make sure to attend Neta's session on Form Recognizer as well, which shows you how the service under the hood here works. Now, I jumped ahead a little bit, and I already told you what's available as services for document workflow automation. So let me kind of click through this slide and talk through it. There's three big capabilities that we're able to offer in Azure services to help you understand the documents that flow through your business. We cover what we call basic optical character recognition, which will extract any piece of string in a document. Whether that string is handwritten or printed, it's this guy's job to extract that for you. Then we have what I'll refer to as customizable form understanding. It's available inside of the Form Recognizer API. And this thing, in a similar fashion to how custom vision works, this thing allows you to tag the key value pairs inside of documents that you care about extracting. So if you need to process, insurance intake forms that have a certain insurance ID you need to parse out, Form Recognizer allows you to do that. And last but not least, we offer receipt understanding. So all of you will go back to your respective companies after this. You'll need to file expense reports. Azure now has a service. It's part of the Form Recognizer service. It allows you to automatically understand the content of receipts. And they don't have to be perfect scans. They can be crumpled images of receipts from your mobile phone. To help me do the deep dive here on document workflow automation, my friend Jason from Knowledge Lake will show you how Knowledge Lake uses Form Recognizer and OCR to drive business value to customers. Thank you, Jason.
So I'm Jason. I'm the VP of Product for Knowledge Lake. Knowledge Lake is a cloud-based content services document automation platform. And we really focus on an organization's most important documents and transactions. So when I say that, what do I mean? These are the content, the documents that really drive, I like the lifeblood of an organization. Auditing a loan and approving a loan, hiring a new employee, adjudicating a claim or paying a bill. These are oftentimes the transactions that, how an organization makes money. This content usually originates outside of an organization. It comes to them from a customer or from a vendor. They don't really have control over what it looks like or how it's filled out. But these are the high volume, high value transactions that help an organization do business. They also are the transactions that need to execute at high velocity. The faster this document workflow automation can execute inside of a company, the more effective they can be. So, high level, what typically happens in most of these processes, content comes into your organization, there's information inside of it, Sometimes it's on paper, sometimes it's digital, sometimes it's an email. That content needs to flow through your business. It needs to get approved. It needs to get audited. It needs to get reviewed. And then that information almost always needs to find its way into a system of record, an ERP system, a line of business system, something like Dynamics 365 or SAP HANA or Workday, so that that transaction can be completed. That's almost always the end result. But the problem is that important information, that business critical content is trapped. It is trapped inside those documents. In the past, the way that we've unlocked that information has been largely manual human effort, right? Somebody sitting at a keyboard looking at an invoice or looking at a claim and typing in those very important key value pairs. Claim number equals, customer name equals, vendor name equals, invoice number, those kinds of things. Or we've leveraged legacy, complicated and expensive OCR applications that took months or quarters, halves even, to implement, and never really reached the full level of accuracy that was promised, which ultimately leaves us back to, again, manual human effort. Quick poll in the room. People collecting content like this, how many doing it with humans? Hands up. Just a handful? Okay. How many doing it with software? How many have to use both? Okay. So Knowledge Lake has partnered with Microsoft and their Forms Recognizer product to make this a lot easier. Specifically, the Forms Recognizer allows us to find those very, very critical key value pairs and table data that exist inside of those documents. Oftentimes, they'll have rows and columns of data in a table. That's also incredibly important to pull off. It doesn't require a lot of manual training or labeling to get started. But most importantly, the Forms Recognizer is not trained on every document in the world. Right? Content from some other organization is not always applicable to your organization. Forms Recognizer is trained based on your content, which incredibly dials up the accuracy. Okay, so how does this work? First, content flows into Knowledge Lake. Scan documents, paper documents, electronic documents, things attached to emails, doesn't matter. We then use Knowledge Lake's classification, which is based on the same computer vision technology, to identify what the document is. First, we need to understand what it is, to understand what facts about that document are important. An invoice is very, very different from a claim. They require two different sets of properties to be extracted. So once we understand what that is, we then pass that content to Forms Recognizer, which then interrogates the document, finds all those incredibly key value pairs, and then extracts all that information and passes it back to Knowledge Lake. We then present that to a user for any QA or correction needed. One of the things that was mentioned earlier by Cornelia is the level in which it's able to handle low quality documents. I talked earlier about this content often originating not inside your organization. That means somebody else brings it to you, and they don't maybe take all of the care necessary to deliver it in a pristine fashion. Things get folded, they get left on the seat of a truck while they're making a delivery, somebody spills coffee on it, those kinds of things. And then finally, we leverage, I told you earlier, the intent is always to drive this content into a line of business system, right? That's usually the end result. And so in the same way that we're trying to drive the human experience out of just sitting there and tagging data, we're also trying to drive the human experience out of doing that data entry into a line of business system. Candidly, the humans in your organization have better things to do than just sit there and key data. And so we leverage robotic process automation to have the software robot using UI automation to do the data entry. Robots type about like a bazillion words a minute. They don't make keying errors. They don't take PTO. At some point in the very, very near future, they will rise up and kill us all. But until then, we're going to use them to do data entry. Maybe, I don't know, maybe that's how you get Skynet. So we have one of my certainly favorite customers that I love to go visit is a craft brewery here in the United States. They make awesome beer. They had They had an existing, very, very complicated OCR application in place. And it really was not fulfilling on the promise of accuracy. They were having to touch way too many documents. They were not getting the efficiency driven through the processes. They were doing a lot of national events, going from city to city, doing events and concerts and trying to promote their beer. And because of that, they had an ever-evolving landscape of vendors. And they were getting ready to open a new location, so they were about to double in size. And so the Knowledge Lake solution was implemented, and we, in weeks, were able to drive the number of documents that they had to touch, the number of documents that required human interaction down by 75%. Those documents that did require human touch required much, much less time because most of it was already done and maybe it needed a slight correction in this one area. So the amount of time necessary every time they touched a document was reduced by 85%. In working with Microsoft, what we found, their vision around cognitive services, computer vision API, forms recognizer, really lined up with some of the Knowledge Lake core beliefs. There's a lot of talk in the last couple of days about trust. Knowledge Lake feels very, very strongly about being trusted with an organization's most critical content. And so there is a promise that Microsoft keeps this data private. They don't use the content that we send to Forms Recognizer and computer vision to enhance their models. They could easily. They could take all of this immense content and make their models better, but they understand the privacy, the sensitive information that's stored inside of these documents. Knowledge Lake also believes in data isolation. We don't like the commingling of data. We don't want two customers' documents and data sitting right next to each other in the same tenant or in the same database. So the approach that Microsoft has given us with isolated customer containers lines up exactly with our strategy. We can spin up an individual container per customer. Data is completely isolated from each other. That also leads back to the previous point of the models being trained based on the documents that you provide and not somebody else, not some other customers. And then finally, we're talking about tens and hundreds of thousands, millions of documents that drive organizations, right? Insurance company processing millions of claims a year. And so we had to be able to reach full enterprise scale. When a customer came to us and said, we're going to do 15 million documents this year, 15 million transactions, we had to be able to answer the bell and achieve that type of scale. And with the Microsoft approach, we were able to achieve that. So thank you.
Thank you, Jason. Jason touches on a key aspect there around data and trust. And when we talk about AI, one of the questions that I get when I usually get off the stage is, hey, do you guys store my data? Answer is no. When you send the data to the cloud, myself and I'm a product person, I work with the engineers and the applied researchers on this stuff. We don't touch that data. We don't label it, no eyes on or eyes off kind of training on it. The data is yours, even when you send it to the public Azure endpoints. Now, with the containerized versions, obviously, you can do on-prem deployments, and that way keep that privacy even tighter. Now, with a few more minutes that we have going here, and I know you all probably wanting to get to lunch, I'm going to touch on one last industry here, which is retail. And then at the very end, I'll show you some of the GitHub repos that we've published. Everything you've seen so far, it's all in GitHub repos whose code you can clone and then try it for yourselves, all right? Fully documented in-depth tutorials. Now, let's jump into retail. So retail is one of these industries where, it's obviously, you hear about it all the time. It's ripe for a lot of AI optimizations, especially in how the physical stores themselves run. Now, there's actually, you don't have to go for the sci-fi, fully cashierless experience just yet. There's a lot of low-hanging fruit in the retail experience that can already benefit from existing computer vision technologies. And for today's kind of retail focus, I actually picked one scenario that's very real. It uses two services in the Azure stack. It uses the custom vision service, and it uses Azure IoT Hub. You'll see a video where a customer talks about essentially detecting produce with custom vision. And they literally went to customvision.ai, and they trained a model to recognize, I believe, 2,000 or so different types of produce. And then they used Azure IoT Hub to get all of that deployed in their own retail store. The customer is called La Comer. It's an actual chain store in Mexico. And let's see if the video now plays. It's a couple of minutes of video, and I'll cut through when it
City
gets to
Market es una cadena de supermercados que está hoy en México en gran auge. Uno de los principales problemas de las tiendas de autoservicio es la merma que se causa en los departamentos de perecederos de frutas y verduras. Con las frutas y las verduras, por naturaleza, no tienen un código de barras en cada uno de los productos por la dificultad de estarlos marcando.
El cajero tiene que memorizar todos los códigos que aparecen. Viene el nombre, el PLU y pues la imagen del producto, ¿no? Entonces, por lo tanto, pues es un poco complicado su aprendizaje, ¿no? El dominio total.
El puesto de cajera en prácticamente cualquier país es uno de los puestos de mayor rotación en las cadenas de autoservicio. Y en países como los nuestros llegamos a tener una rotación hasta del 200% al año. Entonces, el que reduzca su tiempo de capacitación a la mitad del tiempo te genera beneficios económicos inmediatos. Es decir, ¿cómo podemos este proceso simplificarlo? Buscamos para resolver este problema a Microsoft. Empezamos a buscar como una solución juntos.
En diciembre de 2018 fuimos a visitar a la Comer junto con Microsoft. Propuso tener un cajero inteligente donde el reconocimiento de frutas y verduras no se realizara a través de etiquetas, códigos de barras. En este caso, lo que hace la inteligencia artificial es, a través de la cámara, se tomó una foto. Tuvimos que entrenar al modelo para que pudiera reconocer todas las variantes del tipo de frutas y legumbres. Fue un trabajo muy complejo. Actualmente se han utilizado alrededor de 200,000 imágenes de todos los productos. Fuimos subiendo el nivel de precisión hasta lograr un nivel de precisión que es alrededor del 90% hoy en día, 90-95%.
Decidimos hacer el piloto en una tienda nueva. Hoy estamos iniciando, vamos bastante bien.
Es sorprendente que esté la cámara vaya para tomar la foto. Sería una experiencia más rápida.
Entienden los beneficios y el potencial que pudiera tener esto. Es un beneficio que a la larga va a ser para todos los autoservicios, no solo en México. Esto traería para la industria del retail, para la industria del fabricante, unos ahorros enormes.
Creo que lo más importante es que la gente viva, experimente, pruebe la inteligencia artificial y que realmente entienda las capacidades que sí puede lograr y también entienda las limitaciones que hoy existen.
A través de todo este tipo de tecnologías es como vamos a sobrevivir, ser competitivos y ser mejores empresas.
So I love this video because the same service, custom vision, that this customer is using to recognize tangerines versus dragon fruit versus tomatoes, it's the same service that Petra is using to understand different war game figurines in her damn scenario. So the AI that's under the hood is flexible enough that you can scale it to whatever your problem, your object detection problem is. Now, I have some architecture slides here, and you're going to look at them and be like, oh, this is not too complicated, and it's by design not complicated. You are able to put together this similar La Comer scenario in, frankly, 2 or 3 days worth of end-to-end work with debugging and training. It's meant to be simple. If you have an IoT device with a camera, hook it up to Azure IoT Hub. As soon as your IoT device camera now starts being able to capture videos, you can then stream those images into Azure Custom Vision. And then those images that are being live recorded by your camera become the base training in Azure Custom Vision. And you use the service to annotate data, build your own model. You don't need thousands of training images. You just need tens for the majority of use cases. And then you can export that model and feed it back into the same camera that you want to be doing the inferencing. And the inferencing is pretty simple as well. Your camera runs an Onyx and WinML model, and then you don't have to keep the inferencing on the camera alone. You can actually send those images back into custom vision, into the cloud. They go into your own Azure subscription. They don't go anywhere else. And if you send them back to the cloud, you're able to store them and use them as an active learning feedback loop for your ML model. This is it. This is all you need to do to be able to set up a similar custom vision, custom object detection scenario for your business processes. As I said earlier, all this stuff is available for you to get started today. And these are not marketing links that I've linked here. There's a reason that these are not sort of Azure.com type of links. It's because they are real GitHub repos with real code. Let me see if I can get out of this presentation for a second and show you this in Edge. See if we can. So that real-time AI example that I showed you earlier on aka.ms/IoT visual alerts, do we not have internet here? Well, OK. I was actually going to show you the GitHub repo with all of the code that is able to help you recreate that same object detection scenario you saw for the retail chain in Mexico. All of the links that I previously showed you, aka.ms/digital asset management, aka.ms/form recognizer, and aka.ms/IoT visual alerts, they all contain the various get started guides to help you achieve similar end-to-end scenarios. With 5 more minutes to go and no internet, I guess we can take any questions that you folks might have. And if you want to get out early and get yourself lunch, feel free to do so. Thank you, folks. Yeah?
Where did you get your training pictures for the fruits?
Say that again?
And where did you get your training pictures for the fruits?
So the gentleman here is asking, where did we get the training photos for the fruit? So in the La Comer case, it was their own training images. What they did is they used the real camera that you saw in the video to capture some of the training images. Now, they were trying to understand on the 1,000 scale of object types, so they ended up using 200,000 training images. That's what they said there. And those were images that they themselves captured within their store with their setup. Now, 200,000 images sounds like a lot, but when you're actually doing frame segmentation in a video, it becomes quite fast. What you need to then do is ensure that you label those images, which custom vision makes easy as well. So that IoT example that we were showing earlier, all the codes there, including the sample UIs, like how to do the annotation and custom vision. This is a GIF that's based on custom vision, is here in this Git scenario. And all of the code, including the here's how you do the IoT visual alerts piece, is here in this Git repo that you can easily clone. Cool. Any other questions? Thanks, folks. There's also a vision booth in the main hub, so feel free to swing by if you have further questions about either of the topics we discussed today. Thank you.